Welcome to the Math Record. In this video, I'll be covering the second part of the ICTM Regional 2019 Division AA Precalculus, in which I'll be covering questions 17, 18, and 19. Okay, let's begin with 17. The first part just describes the complex numbers. When graphed in the complex plane, the root of 7 to the power 12 equals 1. Determine the vertices of a regular dodecagon. The perimeter of this could be written in this form. Find the sum of the coefficients, basically. So what you need to know is that when you write complex roots of a number, it's always going to be equally spaced around a circle. So we have a circle, that's fine, and it's equally spaced. And you start at the point at the x-axis. So you start right here. So how many points is there? Well, you just look at the exponent. If the exponent is 12, that means you have 12 points. So you just put 12 around the circle that's equally spaced. So there's 2 in here, 1, and then 2, 1, 2, 1, then 2. So that's 12 equally spaced. Right? All these are the same length, etc. So to get it, we need to know that perimeter. We could just cut it right here. And we need to know what this angle is. And this angle is just 360 divided by the 12 because there's 12 side length for a dodecagon. So that gives us 30 degrees. And this is length 1 and this length 1 because they're both radius 1. Because this says z to the power 12 equals 1. And then we just need to find the side length, which is s. So that means s squared, using the law of cosine, is equal to 1 squared plus 1 squared minus 2 times 1 times 1 times cosine of 30, which is just square root 3 over 2. So that is equal to s is equal to 2 minus 2 times square root 3 over 2, that's square root 3, so minus square root 3, and then you have to take the square root of this number. And to get the perimeter, we just need to multiply this by 12. Okay, so let's delete the picture because I need room to do some math. Because we have a radical inside a radical, so we need to actually have a radical plus a radical. So what we could do is we could think about a square root of a minus square root b squared. So then the squared and the square root cancel each other out. So we need to think about this as this. So to do that, we could just have a, we could have just, we know a square root 3 is there, so we have put a square root 3. And square root 3 is pretty big, so let's just make that positive because overall, when you take a square root of something, it has to be positive. So we have, to get a 3 to a 2, we have to minus a 1. So then we have a 3 plus a 1, that's a 4. So and then a 3 times negative 1. I mean square root 3 times 1 is negative square root 3 times a 2 is negative 2 square root 3. So to get this to this is just 2 times as much. So we need to divide this by 2 when this is squared. So that this is the same thing as s. Okay, so then s is equal to negative square root 3 minus 1. I just switched the places over square root 2. And then to simplify, that is just square root 6 minus square root 2 over 2. And then we could just multiply by 12 to get our parameter, which is just 6 square root 6 minus 6 square root 2. Okay, and then we just add the coefficients, which is 12, 6, and 8. And that is our answer for number 17. Okay. Number 18. A set of points in the xy plane consists of all those points satisfying the inequality of x squared plus y squared is less than 1. So it's inside of a circle, radius 1. The graph of this region has numerical area z, which is pi, because area of a circle is pi radius squared. A curve with the equation 1 over x plus 1 over y equals 1 over x times 1 over xy separates the region into two parts. And then you need to find the area of the larger part and then add the coefficients, basically. So let's draw this diagram first. So we have a circle. Okay. And we have that graph 1 over x plus 1 over y over 1 over xy splits into two parts. So if you simplify the left side, that's actually x plus y over xy equals 1 over xy. So we could just say x plus y is equal to 1 and xy equals xy, right? Numerator equals numerator, denominator equals denominator. And basically that tells us that x plus y equals 1. So if you're not sure if that's true, you can always just cross multiply. That gives us xy, x plus y equals xy. Then subtract each other. So then that's distribute out the xy to get x plus y minus 1 equals 0. So that means x plus y minus 1 equals 0. X plus y equals 1, right? It's the exact same thing. So basically x plus y equals 0 equals 1. So we know that this is radius 1. So that means x plus y kind of splits this equation right here. And we can find this larger part. So all we have to do is add 3/4 of a circle plus this triangle. And this triangle is 1 by 1, so the area is 1/2. And the area of this circle is pi. So 3/4 of it is just 3/4 pi plus 1/2. Simplify as 3 pi plus 2 over 4. Add the coefficients and you get an answer of 9. Okay, number 19, sorry. The sum of all values for x in the interval is 0 to 2 pi such that square root 3 sine of x plus cosine of x equals square root 2. So we need to find k. So basically, what we'd like to do when we're working with trig is that we either want a sine squared of x and a cosine squared of x because those add up to 1, and that can help us simplify trig. So to do that, we need to square both sides. So then that would just be 3 sine squared of x plus cosine squared of x. And then we have plus 2 square root 3 times sine of x times cosine of x equals 2. So I noticed that this is a 3 sine of x and this is just a cosine of x, right? Cosine squared of x. So we need to make them the same coefficient. So on this side, we had to add 2 cosine squared of x plus 2 cosine squared of x. So then this would be 3 sine squared of x plus 3 cosine squared of x, get 3 plus, because sine squared of x plus cosine squared is what? Is 1. So times that 3 equals 3. Plus 2 square root 3 sine of x times cosine of x equals 2 plus 2 cosine squared x. And then you can just move this 3 here, right? Which makes this a -1. And a -1 plus 2 cosine of squared of x is basically equal to cosine of 2x. And on this side, 2 times sine of x times cosine of x is equal to sine of 2x. That's just some trig identities. And then we still have the square root 3. So then sine of x divided by cosine of x is tangent of x. Well, tangent 2x because 2x divided by, because there's 2x inside. And then on this side, it's just 1 divided by square root 3. Okay, so we need to find all values of x that makes 1 over square root 3 possible. So if you think about this, how to get square root 3, that's always going to be a 30, 60, 90 triangle. And opposite of the 30 is 1/2. Opposite of the 60 is square root 3 over 2. So if we take a sine of 60, that's square root 3 over 2 divided by 1 over 2, which is square root 3. That's not this, so it's going to be sine of 30. I mean tangent of 30. Tangent of 30 is 1/2 divided by square root 3 over 2, which is 1 over square root 3. So that's right. So we need to get a tangent of 30, or if you think about it in the unit plane, this is 30 degrees. Positive divided by positive equals positive. Or we could go this way, which is also 30 degrees, which is negative divided by negative is also positive. So that's 180 plus 30 is 210. Okay, so we have a 30 degrees and a 210 degrees. But remember, this is not x, this is 2x. So we need to divide the 30 divided by 2, so that's 15. 210 divided by 2 is 105. Add them together, that's 120. So the sum of it is 120 degrees. But we need to write it in radians instead of in degrees. So 180 degrees is equal to pi radians. So cancel them out. 60 divided by 2, 120 divided by 60 is 2. And 180 divided by 60 is 3. So we get 2/3 pi. So our answer for k is just 2/3. And that completes 17, 18, and 19. And I didn't show this in my previous video, but this is all the answers. Okay, well, thanks for watching, and I'll see you at the next math record.